أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم ربي اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. Section 14 Submerged Arc Welding. 14.1 Process. In submerged arc welding SAW, an arc is struck between a continuous bare wire and the parent plate. The arc electrode and molten pool are submerged in an agglomerated or fused powder flux, which turns into a gas and slag in its lower layers when subjected to the heat of the arc, thus protecting the weld from contamination. The wire electrode is fed continuously by a feed unit of motor-driven rollers, which are usually voltage controlled, to ensure an arc of constant length. A hopper fixed to the welding head has a tube which spreads the flux in a continuous elongated mound in front of the arc along in the line of the intended weld, and of sufficient depth to submerge the arc completely so there is no spatter. The weld is shielded from the atmosphere and there are no ultraviolet or infrared radiation effects. See below. Unmelted flux is reclaimed for use. The use of powder flux restricts the process to the flat and horizontal vertical welding positions. Figure 14.1 SAW. Submerged arc welding is able to use where high weld currents owing to the properties and functions of the flux, which give deep penetration and high deposition rates. Generally, DC positive is used up to about 1000 ampere because it produces deep penetration. On some applications, that is cladding operations, DC negative is used to reduce penetration and dilution. At higher currents or with multiple electrode systems, AC is often preferred to avoid arc blow when used with multiple electrode systems. DC positive is used for the lead arc and for the lead arc, and AC for the trail arc. Figure 14.2 Effect of electrode polarity on penetration. Difficulties sometimes arise in ensuring conformity of the weld with a predetermined line owing to the obscuring effect of the flux. Where possible, a guide wheel to run in the joint preparation is positioned in front of the welding head and flux hopper. Submerged arc welding is widely used in the fabrication of ships, pressure vessels, line pipe, railway carriage, and where long welds are required. It can be used to weld thicknesses from 5 mm upwards. Materials joint dot welding of carbon steels, welding low alloy steels, for example fine grained and creep resisting, dot welding stainless steels, dot welding nickel alloys, dot cladding to base materials to improve wear and corrosion resistance. 14.2 Fluxes. Flux is a granular mineral compounds mixed to various formulations. Welding characteristics: more stable arc, improved weld appearance, easier slag removal, higher welding speeds. Weld metal mechanical properties: yield strength, UTS and CEN, amount of manganese and silicon. Acid, neutral, basic, hydrobasic, highly basic types of fluxes. Fused and agglomerated. Fused fluxes are produced by the constituents being dry, mixed, melted in an electric furnace, then granulated by pouring the molten mixture into the water or onto an ice block. Subsequently, these particles are crushed and screened to yield to uniform glass-like product. Advantages of fused flux: good chemical homogeneity, less hygroscopic, so handling and storage area easier. Dot. Fine powders can be removed without changes in composition. Dot. Easily recycled through the system without significant change in particle size or composition. Disadvantage of fused fluxes. Dot. Limitations in composition, as some components such as basic carbonates unable to withstand the melting process. Dot. Difficult to add deoxidizers and ferroalloys due to segregation or extremely high loss. In agglomerated fluxes, constituents may be bonded by mixing the dry constituents with potassium or sodium silicate, and the wet mixture is then pelletized, dried, crushed, and screened to size. Advantages of agglomerated fluxes. Dot. Deoxidizers and allying elements can easily be added to the flux to adjust the weld metal composition. Dot. Allow a thicker flux layer when welding. Dot. Can be identified by color and shape. Disadvantages of agglomerated fluxes. Dot. Generally more hygroscopic, baking hardly practical. Dot. Gas may evolve from the slag as it is melted, leading to porosity. Dot. May be changes in weld metal chemical composition from the segregation of fine particles produced by the mechanical handling of the granulated flux. 14.3 Process variables. Several variables, when changed, can have an effect on the weld appearance and mechanical properties. Dot. Welding current. Dot. Type of flux and particle distribution. Dot. Arc voltage. Dot. Travel speed. Dot. Electrode size. Dot. Electrode extension. Dot. Type of electrode. Dot. Width and depth of the layer of flux. Dot. Elongate electrode angle, leading, trailing. Dot. Polarity. Dot. Single, double or multi wire system. 14.3.1 Welding current. Increasing welding current increases the penetration and wire melt off rate. Figure 14.3 Effect of increasing welding current amperage on weld shape and penetration. Welding current effect on weld profile: 2.4 electrode diameter, 35 volt arc voltage, and 61 centimeter per minute travel speed. Dot. Excessively high current produces a deep penetration or with a tendency to burn through, undercut, or high narrow bead prone to solidification cracking. Dot. Excessively low current produces an unstable arc, lack of penetration, and possibly a lack of fusion. 14.3.2 Arc voltage. Arc voltage adjustment varies the length of the arc between the electrode and the molten weld metal. As it increases, the arc length increases, and vice versa. Voltage principally determines the shape of the weld bead cross section and its external appearance. Figure 14.4 Effect of increasing arc voltage on weld shape and penetration. Arc voltage effect on the weld profile: 2.4 mm electrode diameter, 500 ampere welding current, and 61 centimeter per minute travel speed. Increasing the arc voltage with constant current and travel speed will. Dot. Produce a flatter, wider bead. Dot. Increase flux consumption. Dot tend to reduce porosity caused by rust or scale on steel. Dot help to bridge excessive root opening when fit up is poor. Dot increase pickup of alloying elements from the flux if present. Excessively high arc voltage will. Dot produce a wide bead shape subject to solidification cracking. Dot makes slag removal difficult in groove welds. Dot produce a concave shaped fillet weld that may be subject to cracking. Dot increase undercut along the edge of fillet weld. Dot overlay the weld metal via the flux. Reducing the arc voltage with constant current and travel speed will produce a stiffer arc which improves penetration in a deep weld groove and resists arc blow. Excessively low arc voltage will. Dot produce a high narrow bead. Dot cause difficult slag removal along the weld toes. 14.3.3 Travel speed. If the travel speed is increased, dot heat input per unit length of the weld increases. Dot less filler metal is applied per unit length of the weld, therefore less excess weld metal. Dot penetration decreases, so the weld bead becomes smaller. Figure 14.5 Effect of increasing travel speed on the weld shape and penetration. Travel speed effect on weld profile: 2.4 electrode diameter, 500 ampere welding current and 35 volt arc voltage. 14.3.4 Electrode size effects. Dot weld bead shape and depth of penetration at a given current. A high current density result in a stiff arc that penetrates into the base metal. Conversely, a lower current density in the same size electrode results in a soft arc that is less penetrating. Dot deposition rate. If any given amperage setting, a small diameter electrode will have a higher current density and deposition rate of molten metal than a larger diameter electrode. However, a larger diameter electrode can carry more current than a smaller one, so can ultimately produce a higher deposition rate at higher amperage. Figure 14.6 Effect of increasing electrode size on weld shape and penetration. Electrode size effect on weld profile: 600 ampere welding current, 30 volt arc voltage and 76 cm per minute travel speed. Electrode extension. 14.3.5 The electrode extension is the distance the continuous electrode protrudes beyond the contact tip. At high current densities, resistance heating of the electrode between the contact tip and the arc can be to increase the electrode melting rate as much as 25 to 50%. The longer the extension, the greater the amount of heating and the higher the melting rate, and decreasing penetration and weld bead width. See below. Figure 14.7 Effect of increasing electrode extension on weld shape and penetration. 14.3.6 Type of electrode. An electrode with low electrical conductivity, such as stainless steel, can, with a normal electrode extension, experience greater resistance heating. Thus, for the same size electrode and current, the melting rate of a stainless steel electrode will be higher than that of carbon steel electrode. 14.3.7 Width and flux. Depth of flux. The width and depth of the layer of granular flux influence the appearance and soundness of the finished weld as well as the welding action. If the granular layer is too deep, the arc is too confined, and rough weld with rope-like appearance is likely to result, and it may produce local flat areas on the surface, often referred to as gas flares. The gases generated during welding cannot readily escape, and the surface of the molten weld metal is irregularly distorted. If the granular layer is too shallow, the arc will not be entirely submerged in the flux. Flashing and spattering will occur, and the weld will have a poor appearance and may show porosity. 14.4 Storage and care of consumables. Care must be taken with fluxes supplied for submerged arc welding, which, although they may dry when packaged, may be exposed to high humidity during storage. In such cases, they should be dried as per manufacturer recommendations before use, or porosity or cracking may result. Ferrous wire coils supplied as continuous feeding electrodes are usually copper coated, which provides some corrosion resistance, ensure good electrical contacts, and helps in smooth feeding. Rust and mechanical damage should be avoided in such products as they interrupts smooth feeding of the electrode. Rust is detrimental to weld quality generally, since it is hygroscopic, may contain or absorb moisture, so can lead to hydrogen induced cracking. Contamination by carbon containing materials such as oil, grease, paint, and drying lubricants. It is especially harmful with ferrous metals. Carbon pickup in the weld metal can cause a marked and usually undesirable change in properties. Such contaminants may also result in hydrogen being absorbed in the weld pool. Welders should always follow the manufacturer recommendations for consumables, storage, and handling. 14.5 Power sources. In arc welding, it is principally the current which determines the amount of heat generated, and this controls the melting of the electrode and parent metal, and also such factors as penetration and bead shape and size. Voltage and arc length are also important factors, with increasing voltage leading to increased arc length and vice versa. Usually in the SAW, a constant voltage or flat characteristic power source is used. Power can be supplied from a welding generator with a flat characteristics, or transformer or rectifier arranged to give output voltage of approximately 14 to 50 volt, and the current according to the output of the unit can be in excess of the 1000 ampere.